All right, in section 2, we're going to look at how we can display quantitative variables, those that can be represented by a number. So the problem with a quantitative variable versus a categorical variable, we had these different categories, and we find out how many are in each category and make our bar graph or our pie chart. The problem with quantitative variables is there are a lot of numbers that could be represented by some data set. For example, here are some numbers that represent the combined scores for 2 weeks of NFL games. So taking both team scores and add them together. So if you look at all these numbers, we have a lot of different values. So if I made a bar chart with all these different values, there'd be a ton of numbers, and also there'd only be usually 1 or 2 at most of each data point in there. So what we typically will do is, instead of making them each their own little data point or own little section, we put them into groups, or what we call bins. And this is how we'll make our big quantitative graph, which is called a histogram. So if you look at all these numbers, instead of going ahead and listing them all, let's go ahead and make our bins, which are going to be a range of numbers. So for example, I've broken mine into 15 to 24, 25 to 34, 35 to 44, 45 to 54, 55 to 64, 65 to 74, and 75 to 84. Now the big thing you want to do is you want to make sure you have equal widths in these bins. You want to make sure that each of the categories is the same length. So in this case, 9 is our width. So if I look at this histogram, or trying to make this histogram, I want to figure out how many of each of these data points are in these bins. So if I look for 15 to 24, I'm just going to cross them out. There's 1, there's 2, there is 3, and there is 4. So there are 4 in the first bin, or the first category. So we can just do this for all of them. I'm not going to count these out individually, but there are 3 in this one, 13 in this one, 6 in this one, 3 in this one, 2 in this one, and 1 in this one. Okay, so you can trust my counting ability, but if you want to go ahead and verify it, feel free to pause the video and check that. So we make a histogram. A histogram is essentially going to be a bar graph that uses these numerical values. So on our x-axis, I'm going to make this the combined score. And then on the y-axis, I'm going to make it just count or frequency, whatever you want to call it. Okay. So what I do is my first class starts with 15. But instead of putting 24 to end it, which would kind of be what you'd think would be, what we're going to do is we're going to put the beginning of the next one. So our histograms are always defined by these beginning numbers. Because in a histogram, as opposed to a bar chart, we want all the bars to touch, because numbers have this continuum where there should be no gaps in the numbers. So we'll have 15, 25, 35, 45, 55, 65, 75. Now, if you notice, our last one goes from 75 to 84. So if I start at 75, I have to end it. So I'm going to put 85. Even though 85 isn't really a class, if I was going to have another one, it would obviously start with 85. So you have to always make that one additional one. And the reason we do this, so let's just go ahead and make the scale here. I'm just going to make it go by 2s. 2, 4, 6, 8, 10, 12, 14. That should be plenty. So when I make my bars, I'm just going to go ahead and take this count. The first one is 4, so I'll just make a bar like this. So if I don't put that 85, I won't have an ending point for my last bar. So then we're down to 3, which is something like this. Our next one is 13, which was our biggest one, so going to look something like this. 45 to 55 was 6, so something like that. 55 to 64 was 3, so that's going to be the same as this class down there. 65 to 75 is 2, and then 1, make it a little smaller. So this is what our histogram looks like. So obviously you can see the highest number, we're in that 35 to 44 bin. But you got to remember, if I would have made the bins different, if I would have made them wider or narrower, I would have got a different picture. If I would have went 15 to 34 and had 7 in there, I would have had less bars and it would have been a different shape. So histograms in general are very dependent on how wide you make those bins. Now, later on in class, we'll work on making these with Google Sheets, and you will see that there's some pretty nice features where Google will actually pick a pretty good size for these histograms. Okay, we're going to go ahead and look at a different type of quantitative graph. The second one we're going to look at is a stem and leaf. Now, the nice thing about a stem and leaf is it will actually keep all of your data there. So we're going to do an example on the pulse rate. Now, if we did this in class, we could take our pulse rate and things like that, but I'm just going to go ahead and give you some data to find your average pulse rate. So I went ahead and I have some data that I made up, to be honest with you. And I have some male and female, and I have found their average pulse rate. So the first person was a female with an average pulse rate of 63. Second was a female with a pulse rate of 88. Then a male with an average pulse rate of 46. Female with a pulse rate of 50. Female with a pulse rate of 68. Female with a pulse rate of 66. Female with a pulse rate of 76. Female with a pulse rate of 65. Male with a pulse rate of 69. A male with a pulse rate of 61. Male with a pulse rate of 61. A female with a pulse rate of 70. Female with a pulse rate of 52, and a female with a pulse rate of 90. Okay. So we're going to take this data and we are going to create what's called a stem and leaf plot, or a stem plot. Okay. Now a stem plot is going to kind of be a histogram where we're going to break it into different parts, but essentially we're going to take both parts of the numbers to be what we call the stem and leaf. So for example, if I take a number, I'm just going to pick a random number here. I'm going to pick 52. So 52 has two parts. It has a 5 and a 2. So a 5 and a 2, the 5 is the tens spot and the 2 is the 1 spot. So I'm going to do 5/2. So 5 is going to be what I call my stem, and 2 is going to be what I call my leaf. Okay? So 5/2 still means 52 beats per minute. We just separate it into two parts. So the purpose of doing this is we look at all of our stems. So I'll do one for all the pulse rates here. So I'll do a combined one here. So I have 14 data pieces. So if I look at my numbers, my smallest one is 46 and my largest one is 90. So if I look at the tens place on there, all the tens places are 4, 5, 6, 7, 8, 9. Those are all of my tens places. So if I look at the 14 numbers, those are the tens places. Now if I look at the second part of, say, 4, the only 4 was 46. So what I do with the other part is I put it on the other side of the vertical line. So we have the stem on the left and the leaf on the right. Now it's very important you make sure you have a key so we know which part goes where. So 4/6. So for 5s, it looks like we have 50 and 52, so I'll just put those two leaves right next to each other. Then for 6, I have 2 61s, a 63, a 65, a 66, a 68, and a 69. I have a 70 and a 76. I have an 88 and I have a 90. I put 99, so 90. There you go. So this is somewhat like a histogram because if I make little blocks around here, then what you're getting essentially is a histogram that is just facing the different direction. So we just have this histogram that looks like this, okay? So if I take it and flip it this direction, you can see it kind of looks like a histogram, which is each of the classes being set at being 10 units long. So there is my stem plot. That's how you do a singular stem plot. You just put the first part of the number on the left of the vertical line, and then each corresponding leaf to the right. Now, that was a stem plot, just putting all the data together. Sometimes you might want to separate it so you can see both sets of data and try to compare them. So we call this a back-to-back stem plot. So obviously we had two categorical variables, male and female, we can break this into. So I have the same stems, so if I was going to do a back-to-back, so I have our stems of 4, 5, 6, 7, 8, and 9. Now for males, there was only 4 males in this data set. We had 46, so I'm going to go ahead and put the 6 to the left, just because I have the males on the left. Even though it looks like 64, our stem is on the right, and our leaf is tailing off to the left. The only other ones we have for males are the 61, 61, and 69. So I'm just going to put 1, 1, and 9. Now there's nothing with a 5 or a 7 or an 8 or 9, so that just gets left blank. So essentially this histogram is going to look like this, and then a missing spot, and then a bar here. Now if I do the females, there was none with a 4, but there's 2 with a 5, 0, 5, 0, 2, 63, 65, 66, 68, and then 70 and 76, 88, and 90. So again, you can kind of see this histogram with these bars. So obviously that you can tell a couple things from this back-to-back stem plot. One, there's a lot less data collected on males than females. You can see that there's a lot of the female data is kind of crunched right around here. As for the males, they're mostly right here. You have that one value that's kind of off, but you can kind of see the pattern as you look at these two. Now, if you have more data, sometimes it is helpful to try to see how big your values are going to be, how many are in each data point, how many are in each column. The last kind of stem plot that we're going to look at is a split stem and leaf plot. Now, this is one that you can use, so you can imagine if I were to do something like age of high school students, most of them would start with a 1, 16, 17, 18, 19, 15, 14, somewhere in that range. So that would be not a very efficient way to make them all that way. So if you want to split it, what we can do is we can basically, if you think of like teens, maybe we can go from 10 to 14 and then 15 to 19. So you can split it that way. So you can make it, you can actually have 2 stems. So we can do that. Let's look at just this data. This is some data for some scores on last year's Unit 1 test in our quantitative analysis class. So if I look at doing a split stem and leaf plot, my stem is going to be here, but I'm going to have 2 6s, because I believe if I look at the lowest score, it is 62, and the only other one that starts with a 6 is this one, which is 69. So I'm going to have my stem and leaf. Now the first 6, we're going to go from 0 to 4, and the last one 5 to 9. So obviously the 2 would go here, and the 9 would go here. Okay? So if I want to do a key, I should still do a key, so maybe I'll do 6-2 is 62%, just so I know what I'm looking at. And then I'll do 2 7s. Now, if I look at the 7s, I had 174, because again, this one's going 0 to 4, the second one's going 5 to 9. I had a 75, a 78, and a 79. I have 2 8s, so I'll do 8 and 8, and I have 2 80s, an 82, an 84, and 84. Now my bigger 80s are 88, 88, 88, 88, 88. Very popular score apparently. Then again, I'll do 2 9s. I did not have any perfects, so I don't need to go to the 10 for the stem, so 9. So I had 2 90s, I had 2 92s, a 93, and a 94. And then finally, the highest score in the class was a 96. So again, there's kind of you can see your shape of your stem plot as you put the bars here, and then we have these, oops, the bar goes here, here. So you can kind of see that shape. Now the nice thing about a stem plot in general, split, to back, whatever, you don't lose any of the data. So for the bins, when we said put them in bins, it's how many goes in each one. Well, you kind of lose the original data. Where these stem and leaf box plots, the data is still here, so we're not going to lose that. Our last kind of graph we're going to look at is a dot plot. Now a dot plot's very simple. A dot plot is when we just have one dot represent each data value. Okay? So how we're going to make a dot plot is we're simply going to make one axis, and we're going to label with our variable. So this is some data for some quiz scores. So out of 50, so quiz score out of 50. Now in this case, unlike a histogram, we're going to make each single dot have its own spot. So I'm going to go ahead and just label this. The lowest dot I see here is 26. So I'll go 25, 26, 27, 28, 29, 30. 31, 32, 33, 34, 35, 36, 37, 38, 39, here's 40, 3, 4, here's 45, 1, 2, 3, 4, here's 50, which should be our biggest value. So if I look at it, my smallest data value is at 26. So for a dot plot, you literally just put a dot above 26. So 30 I had a score, 31 I had a score, or not 31, it was 32. I'd have to skip 31. 34 was the first one that had multiple. 34 had 3 people get that. One at 36. 38 had 5 scores there, so I'm going to put 5 dots. And then 42 was the next one. It had 7. 1, 2, 3, 4, 5, 6, 7. And that's just because that's how many there were. So if you were making this, you would have to actually go through and count how many of each one of these there are. There's 3 44s. There was a 48. And there was a 50. So there's my dot plot. So essentially, these dots become the height of our bars in our quasi-histogram. Now, you can definitely see the problem here. We have all these gaps where there's no data. So all these gaps where there's no data becomes a problem. I mean, the good news is you get a general idea of where the most are, what the distribution kind of looks like. But that is one issue you sometimes get with a dot plot. So those are 3 types of quantitative variables we will look at. And again, we'll look at more as we move further into the course.